It's called stoichiometry, and we're going to do using chemical equations. Information given by chemical equations. Here are the objectives: to understand the information given in a balanced equation, and then to use that balanced equation to determine relationships between moles of reactants and moles of products. A balanced chemical equation gives relative numbers or moles of reactants and products for the molecules that participate in a chemical reaction. For example, 2H2O yields 2H2 plus O2. 2 moles of water yields 2 moles of hydrogen and 1 mole of oxygen. The coefficients of the balanced equation give the relative numbers of the molecules. 2, 2. 2, 2. 1, 1 understood. The coefficients of a balanced equation give the relative numbers of molecules. For example, here it is in picture form. 2 water molecules yield 2 hydrogen molecules and 1 oxygen molecule. 2, 1, 2. Let's review. The information conveyed by the balanced equation for the production of methanol, CO plus 2H2 yields CH3OH. 1 molecule of carbon monoxide plus 2 molecules of hydrogen plus 1 molecule of methanol. And it also can mean the number of molecules. So 1 mole of carbon monoxide can also yield 2 moles of hydrogen, 1 mole of methanol. So these coefficients can be molecule, particles, molecule numbers, or moles. This is the combustion reaction for propane, a common fuel for cooking with gas grills. It is represented by the unbalanced equation here. So we want to give the balanced equation and state the meaning of the equation in terms of the number of molecules and moles for the molecules. So you first have to balance, and here's the solution. So you want to make sure that you have the same amount of carbon on both sides, hydrogen on both sides, and oxygen on both sides. So here's the balanced equation, and you have a coefficient of 1, 5, 3, and 4. This equation can be represented or interpreted in terms of molecules, in terms of moles as well. Molar mass can be compared also, mass per grams, which will be explored in a future lesson. The end.